students of first year, first semester of Shahdar, of the Department of Physics, Shahdar University of Science and Technology. I have been teaching you the course Mechanics Physics 1-1 for about 1 month. On and off, I have missed some classes, but 6 classes has been already delivered. So today's class is the 7th class. So this is the Mechanics 7th lecture I am giving to you. Today we shall discuss frictional forces. Frictional forces, you all know, is a contact force. Whenever one body, solid body, tries to slide over another solid body, then frictional forces come into play. One body opposes the motion of the other body. Say, I have a block of mass m moving with velocity v0. I have a block of mass m moving on a table. This is the table. This is the table. So here is the block. Here is the block of mass m. This moving with velocity v0. With velocity v0. This is a vector quantity. This block of mass is sliding over the table. Then you will find that the motion of the block eventually comes into rest. The body does not continue its motion. The block cannot continue its motion. The block comes to rest. Then what can I say? We can say that there is an opposite force opposite to the motion of the block. Opposite means opposite to the motion of the block, there acts an acceleration or force which stops the motion of the block. This opposing force is called a frictional force. So, as we know from Newton's law, every acceleration can be associated with a force. So, we can say that the frictional force is here, F equals M A, I write it in here, A value. So, because we don't know what actually is the acceleration, this acceleration usually changes. It goes a little bit up, little bit down. So, you can associate only an apparent acceleration with the motion. So, whenever a solid body moves over another solid body, an opposing force acts upon the moving body, which can be quantified by Newton's law as frictional force small f is equals mass of the block multiplied by an average acceleration. So, this is the main point of friction. Friction is a contact force. Friction opposes motion of a body whenever a body, solid body, wants to move over another body. Okay. It is an universal force. This is an universal. In art, we do many things. We move many things over road, over table, over our beds. We continue to doing such things. That means moving one body over another body. Whenever one body moves over another body, frictional force come into play. Okay. The second question is, direction of frictional force is such that it opposes the motion of the first body. Second, the frictional force automatically comes into play, and automatically it opposes the relative motion of another body. And there is also another thing that should be known. That is, when one body does not move over another body, but just sitting on, even then there is a frictional force. One body is sitting over another body, even then there is a frictional force. So let's do some experimental work again. Here, a force in this block, the block is over the table. There is the weight of the body acts downward given by mg. This is the acceleration due to gravity. This is the weight of the body. And then acts another force that is called the normal force, and which acts in the upward direction. Now say we don't have this velocity V0 at this moment. Forget about this V0 right now. Forget this. We apply a force M in this direction. We apply a force in this direction. The force is at first small. The force is at first very small. Whenever the force is small, the block does not move. Let's increase the force. As we increase the force, the body does not move. But suddenly the block starts to move. Suddenly. So the force we apply is not sufficient at the beginning. When the force we apply is sufficient, then it overcomes the frictional force and the block starts to move. Right? You understand this? Okay. Then what will be the frictional force? The frictional force will be in this direction. Right? The frictional force will be in this direction. So, as long as F is small, this and that F, then balances, no motion occurs. Whenever this F, our applied force is sufficient, it will overcome this F and the block will start to move. Okay. So, you easily understand that there is a maximum of applied force. There is a maximum of applied force when the motion begins. There is maximum of applied force when the force begins. Now, let's plot the empirical facts, the experimental facts of this experiment. We'll draw a graph. Say, in this direction, we write time in second. In this direction, frictional force. Say this is 1. In arbitrary Newton, in Newton, this is 2. This is 0. Time is 0. Here is 2 seconds. Here is 4 seconds, 6 seconds, 8 seconds, 4, 6, 8, 10. So the experimental findings are such that whenever there is no friction, the body does not move. The frictional force is 0. Now, at about t equal to 2 seconds, the body starts to move. Firstly, frictional force is increasing. Why? Our F is increasing, F is also increasing. Applied force is increasing, the frictional force is also increasing. There is no motion, no motion. Suddenly, when at about t equal to 2 seconds, the force is about 1.5 Newton. Applied force, the frictional force is also same. F is equal to 1.5 Newton. At this time, what happens? The block starts to move, and this is a sudden experience, sudden happening. Then what happens? You can reduce the applied force. If you reduce the applied force, frictional force also reduces. If you reduce the applied force, frictional force also reduces. So you reduce some applied force, even then the block moves. And then what happens? Frictional force is constant. Okay. Frictional force is constant, that is our applied force is also constant. So the motion will be what? Motion will be uniform. So over a board table, you can move a solid body with uniform motion, applying certain force which is requires, which balances the frictional force. Okay, next. Now come to the point that there are two types of friction. One is called static friction. At the beginning, I have said that whenever a body rests over another body, then also there is frictional force. So static friction, what is static friction? Static friction is when two bodies are at rest or one over another. Static friction. This will be called force of friction when the bodies are at rest over one and they are static. That means you have the table. Over the table there is a block. The block is sitting just still. Even then there is a frictional force, and that force is called static force of static friction. Okay, now to this part. What is the maximum of frictional force here? Our 1.5. This is the maximum of frictional force. The maximum of frictional force, this is what in this portion no motion actually happens. So the maximum of static friction here in this example is what? 1.5, and it happens at about 2 seconds. At about 2 second time, the maximum of frictional force happens, and this is the maximum of force of static friction. So maximum force of static friction, this is what I have raised the previous picture. Our applied force, we apply force, then the body suddenly starts to move. The minimum of applied force which we apply, the minimum of applied force is equal to the maximum of static friction force. The minimum of applied force is the minimum of the maximum of the static frictional force. This should be known by you. And second fact, you can reduce the static frictional force. You can reduce the static frictional force even after the motion has started, and you can continue with uniform motion. Okay, kinetic friction. Kinetic friction is for this portion. In this figure, kinetic friction is constant. Kinetic friction is constant. In the static frictional case, you have seen that maximum of frictional force is the minimum of applied force. So there is a inequality. There is an inequality. And in the kinetic friction case, there is no inequality because the graph is straight. That means kinetic friction, what is kinetic friction? Kinetic friction is the frictional force acting between surfaces whenever both of them, when one body is moving over the other. This is the friction of kinetic force. So these facts are found by experiment. These cannot be postulated. Say gravitational force of Newton. Gravitational force of Newton. Newton did not do any experiment to find F equal to gm1 m2 by r square. He speculated. He proposed that this will be so. So that is not empirical. But this frictional force, this is experimental fact. By experiment, we discovered this thing. And there are two laws, they are called empirical laws. Two empirical laws. Two empirical laws for this frictional forces. Experimental laws. Number one, the maximum force of static friction is approximately independent of the area of contact. What do you mean by this? The bodies to be bigger or smaller. No another thing. Frictional force is always case sensitive. Whenever you change the two surface, a pair of surface, the frictional forces changes. Frictional force is always for a particular pair of surfaces. Okay. For a particular pair of surface, two surfaces, for a particular pair of surface, the maximum force of static friction independent of the area of contact. If the one body is bigger or smaller, the maximum static friction force does not change. Maximum of the static frictional force remains constant, even if you take large body or small body. And the second law is, it is maximum force of static friction is proportional to the normal force. This is very important. This will help us quantify frictional force. Frictional maximum force of static friction is proportional to the normal force. What is normal force? I have discussed this normal force in a previous class, in the 6th lecture. Whenever one body is over another body, the second body applied an upward force to the first body, which acts perpendicular to the surface. This is the normal force. So, static friction, the force of static friction proportional to the normal force. Of what? The maximum of static friction. Okay. So, we can quantify, that means write a formula for frictional force say for static friction, we can write a formula. Formula for static friction. Fk less than or equal to mu k n. Whenever this is equals, then what you see, Fk is maximum, right? This side means this side is greater. Whenever this is equal, both sides are equal. In that case, Fk is what? Maximum, right? Fk is less than this. Fk is less than mu k n. Whenever there is equal sign, Fk is what? Maximum. In that case, mu Fk is proportional to normal force. Here, Fk frictional. No. I'm sorry, guys. I'm sorry. This is Fs frictional bracket static force. Mu not k, mu s. I'm sorry, guys. Mu s. And coefficient of static friction and normal force. Okay. Static frictional force is maximum when there is equal sign. In that case, what do you have? Fs equals us n. You see what? The second law. Maximum of frictional force proportional to normal force. And whenever Fs is not maximum, us n is greater. Whenever Fs frictional force is less than this maximum, then Fs is less than us n. Whenever Fs is maximum, Fs is proportional to normal force. Okay, these are two empirical laws, experimental laws, empirical or experimental laws. For kinetic friction, what is kinetic friction? Whenever one body, solid body, is moving over another solid body, then the that frictional force is called kinetic frictional force, or force of kinetic friction. Force of kinetic friction. For that also, these two laws holds. Only change here the static. Right here, kinetic. For kinetic friction, that same two law holds. But instead of static, you write here kinetic. So I am not going to write these two laws again. You understand? Just understand that for kinetic friction, both of these two laws applies, but you have to change the word static by the word kinetic in these two laws. And the formula which will help you to find the numerical values of frictional force. Formula for kinetic friction is Fk equals inequality. Because in the graph you have seen this is straight line. Fk is equals what? Mu k. Fk is constant and it is proportional to normal force. Say a second law, it is proportional to the normal force. But here you don't have to write this maximum. force of kinetic friction is proportional to the number of force. And here the force of kinetic friction is equal to the independent of the rate of time. Experimental laws for kinetic friction. Right? Now you can copy this. Now you can copy this. These are the two laws for kinetic friction. Force of kinetic friction is force of general force. Force of kinetic friction is approximately independent of the idea of contact. And the law is Fk is equal to mu K. What are these? Fk, force of kinetic friction. Mu K, coefficient of kinetic friction. M as above normal force. Okay, now some remarks. Mu S, mu K are dimensionless constants. Their value is case. I have suppressed many things here, many words here. The values are case sensitive. What do you mean? If you change the pair, values will change. If you change the pair, values will change. Case sensitive. For a given pair of surfaces, usually mu s is greater than mu k. Mu s is greater than mu k for a given pair of surfaces. Both of them can exceed 1. They are dimensionless constants. They are dimensionless constants, so you need not write any unit here. So mu k and mu s can exceed 1. But commonly they are less than 1. Commonly they are less than 1. So this was a simple physics, not hard to understand physics, very simple physics here written. But you have to do a labor. I am giving you some homeworks. So write down the homeworks and do this by yourself to learn more about frictional forces. The homeworks are from Restic Hereditary. Restic Hereditary, chapter 5. Restic Hereditary, Chapter 5. Sample problems. Sample problems. 5.8 and 5.9. These are homeworks. And do all the multiple choice problems of 5.2 and 5.3. These are the homeworks we have to do to understand more about friction. So I am going to give a title to today's lecture. This is Mechanics Lecture 7 by S.D. Faruque. Over and out. My students, stay at home and be safe.